It is given that a lady uses 1.5 diopter glass to have normal vision from 25 centimeter onwards. That is, when this glass is used, the eye along with the glass is behaving as a normal eye, having 25 centimeter the near point. She uses a 20 diopter lens as a simple microscope to see an object. Find the maximum magnifying power if she uses the microscope together with the glass, and the second part they are asking without the glass. And let's check. Just as a rough figure, suppose this is the eye lens. This is eye, and this is the lens that is used, of course, convex lens. The person is suffering from hypermetropia because the glass that is used is having plus 1.5 diopter as the power. So what is the focal length then? That focal length is 1 by 1.5, that is 2 by 3 meters, or it is 200 by 3 centimeter is the focal length. Focal length is 200 by 3 centimeter. And any object which is placed at 25 centimeter, of course the eye naturally will not be having the near point here. The eye will be having its near point somewhere here. So that the object, if is placed at 25 centimeter, the ray of light slightly bends and the eye lens feels that as if the ray is coming from this point. So by using this convex lens formula, 1 by v minus 1 by u is this minus 25, is 1 by f. F is how much? 200 by 3. We can calculate v is minus 40 centimeter. So this near point of this eye, it has gone up to 40 centimeters. Sorry, it is 40 centimeter. This is the near point. This is the near point of the eye. Then what they are asking is, if she uses the microscope together with her glass. So first part is, in first case, the microscope whose focal length is how much? Focal length, it will be equal to 1 by the power, which is equal to 1 by 20, this much meters, and this is this much meters, this is equal to 5 centimeter. The microscope acts as magnifying glass because the microscope or simple microscope will be very close to the eye. Therefore, for that the magnifying power will be 1 plus d by f, where d is simply 25 centimeter and f means for that 5 centimeter we will be using. So 1 plus 25 by 5, and this is 6. The magnifying power is 6. Now in the second case they are asking that without the glass. So now without the glass the eye is having a near point of 40 centimeter. So in second case, without the glass, the least distance of distinct vision we just now we calculated is 40 centimeter. Therefore the magnifying power for that hand lens or simple microscope, it will be equal to 1 plus d by f. 1 plus 40 and f is 5, so it will be 9. So in the second case the magnifying power is 9. Do the answer suggest that an object can be more clearly seen through a microscope without using the correcting glasses? That is, the magnifying power we are getting as 9. Actually what happens that if we use it, we will be seeing the magnification here, but at a large distance we will be seeing. And at a large distance, what happens that the clarity of vision may not be as satisfactory as it was when it is at less distance. So at a large distance it may be subtending a small angle at our eyes. That can be a suitable reasoning for this.